I've prepped a few more pictures just to finish off 17.2. So page 253. This is question 4. Now, let's go back to yellow so we can see what we're doing. It says the hexagon, that's that one there, consists of 6 equilateral triangles, where they would be if it's a regular hexagon, wouldn't they? And each has an area of x centimeters. So all these, x squared. So all these have an area of x squared centimeters, squared even, because it's an area, isn't it? So it's measured in centimeter squares. The area of the rectangle is 16 centimeters squares less than the area of the hexagon. So we've got to form an equation. It says form a quadratic in x and solve this to find the dimensions of the rectangle. In other words, how wide am I and how tall am I? Length times width, essentially. So let's read the English very carefully. The area of this rectangle is 16 centimeters squares less than the area of the hexagon. So guess what? This is smaller than this. How do we make them equal? Well, the area of the hexagon will be equal to the area of the square if we can add 16 onto the square. Is that alright? So read English again. The area of the rectangle is 16 centimeters squares less than the area of the hexagon. So if I give this rectangle 16 centimeters squares and lump it all together, I get the equivalent of the area of the regular hexagon. So in picture form, that's my equation ready to go. Now I've got to form an equation and then solve it to find the dimensions of the rectangle. So let's get working. Right, well that's 6x squared straight away, and that equals the area of the rectangle plus an extra 16. Well, here's the area of the rectangle. It'll be the length times the width, and then we're going to add 16. Okay, there's my equation. We need to tidy it all up, so let's just do that. 4x squared, 8x, an extra x, plus 2, plus the 16 at the end. Keep tidying, simplifying. 4x squared, 9x, 2 and 16, 18. Alright, it's getting tidier and tidier. Bring everything next door to the left. So 6x squared minus 4x squared minus 9x minus 18 all equals to 0. Got myself a quadratic. 6 take away 4, 2x squared, take away 9x, take away 18 equals 0. No other common factors in terms of extracting a number from each of these 3 terms. Go straight into the 2 main factors, the 2 only factors in fact, 2x and x. How do we make 18? Well, 1 and 18 sounds a bit out of the way. 2 9s, I'm unlikely to get a 9 out of that. I'm going to opt for 3 and 6, so 3 6s. So if I put I don't know, let's just try a 3 there. Actually, let's put a 6 there and a 3 there and see how we go. Right, 2x times x, 2x squared. 2x times 6 will be 12x, and 3 times x is 3x. 12x and 3x will give me a difference of 9, so I'm happy with that. So I want to go for minus 6 there to get minus 12x's, and a plus 3 there to give me plus 3x's, minus 12 plus 3 minus 9x. We've got it right there on the screen. And of course, just to confirm it, 3 times minus 6 is minus 18. Won't even check it. I'm totally, I'm trusting that. Right, let's solve. I've got 2x plus 3 equals 0. So x is going to be minus 3 over 2, which is minus 1.5. Okay, so I took the 3 over and subtracted and then divided by 2. Here I've got x minus 6 equals 0, from which x becomes 6. And of course these answers are in centimetres, aren't they? Because the originals are given in centimetres. Right, form an equation, done it, quadratic, solve it to find the dimensions of the rectangle. Well, let's just work in a different couleur here. I now know that this value is worth 6. Don't substitute the negative value in there, silly. And I know that's worth 6 as well. So what have I got here? I've got 4 lots of 6 plus 1, which is 25 centimetres that way. And I've got 6 plus 2, which equals 8 centimetres that way. So my dimensions are 12 centimeters by 8 centimeters. That's a really nice question. Problem solving question. It's lovely. Let's just turn over, do another one or two. Right, now this is me drawing question 5, not with a lovely orangey background that's in the book, but with a lovely fancy background that I've got there. That is the theme for this chapter. So I've drawn a crude picture of the net of a box there. It says a box is made from a rectangular piece of card, and didn't bother drawing all the dotted bits across there. And it's formed by cutting out a square from each of the corners. Okay, so that's a square. And what I thought I'd do is just to show how it all fits together. So what I've done is join that to that, that to that, that to that, and that to that. We have an open top box. So here's the box. This is how it would look. So the length of x plus 5 centimeters is effectively that one. The width of x there and there, all these are x's, is effectively the width across the bottom there. And these are all heights of 4 if you put them together. So there it is. That's essentially what I've got. And it doesn't ask me to do that, but it's for teaching purposes. It's good to see how the box fits together. It says write down in terms of x, expressions in terms of x for the length. Well, the length is going to be x plus 5. Yeah, I've got that one. The width, well, that's just going to be x alone. There's the width. And the height of the box, doesn't ask me for the height, but basically the height is 4 centimeters. That's it. Now that's part A done. Now part B is where it's at. The volume of the box, and I'll write this down for you. The volume of the box is 144 centimeters cubed. Find the dimensions of the original piece of card. Okay then. The original piece of card. Let's be careful. Now, how do you get a formula of the volume of a box? Well, a box is width times height times length, or essentially that times that times that. So let's just do that. We've got x plus 5, multiply that by 4, and multiply that by x, and that will all come to 144 centimeters cubed. That's my equation. So what have I got? I've got 4x multiplied by x plus 5 is 144. Multiply out 4x squared plus 20x, bring the minus 144 to the left hand side, minus 144 equals 0. Now, I'm sure I can divide by 4 if I'm really clever, just to simplify down this quadratic. So, I'm now going to divide by 4. Here I go. X squared plus 5x take away. Well, I know 12 goes in there 3 times, so I reckon 3 fours will be, I'm not sure, let's ask the calculator. Let's divide by 4, so not being clever. 144 divided by 4 is 36. Yeah, I knew that. So that's 36, in other words minus 36 equals 0. And that's been reduced down to a very easy grade B quadratic. So now we can factorise the thing, can't we? I've got to get the dimensions of the original piece of card, which I will just begin to dot in anyway. The original card goes like that. And if I can work out all these extra little bits and pieces, that'll be fine. So that's where I'm going to go later on. Right, x and x is x squared. 6 sixes are 36. Well, I don't like that because a 6 and a 6 won't give me a 5. But I can see that 9 and 4 will give me 36 if I multiply it, and the difference between 9 and 4 is 5. So I think I've got that right. Now I want plus 5x. So I put a plus there in front of the 9. That'll give me 9x's. Put a minus there. End up with minus 4x's. Look at it carefully. X times x, x squared. Lovely. X times 9, 9x. Minus 4 times x, that's another minus 4x's. So 9x minus 4x is 5x's. And minus 4 times 9 is of course minus 36. Now we can solve it straight away. X minus 4 equals 0, and therefore x equals 4. The other solution of course is x minus 9 equals 0. X plus 9 equals 0, so x equals minus 9, and which we'll ignore because we don't want any negative lengths. So let's just highlight this one as the solution that's sensible to our lives. And now I've got x is 4. Let's go back to black for a minute. It does say form a quadratic and solve it to find the dimensions of the dimensions of the original piece of card. Now I know x is 4, so I'm going to put a 4 right there. We'll put 4 right there. So what are the dimensions? I've got 4 plus 5, and we know it's 4 across there as well, and it's 4 across here as well, and it's 4 there to there. X is 4, and that's also 4. Holds really well, doesn't it? I think. Let's just check that again. X, it's got to be 4. That's the same as that, and that's the same as that. It's got to fit together beautifully, otherwise the size just won't work. Yeah, so what have I got here? I've got 4 plus 9. 4 plus 5 is 9. I've got 4 plus 9 plus 4. That's going to give me 17. Therefore, I've got 17 centimetres by 4 plus 4 plus 4, 12 centimetres. And these are the dimensions of the original piece of card. I cut out a little square. It does say I've cut out a square. 4 by 4 there, the 4 by 4 there, 4 by 4. So all these little lengths here are 4s. So that's it. The original piece of card was 17 centimetres by 12 centimetres. And let's just move on back to yellow. This is a very accurate, beautiful representation of question 7. It says a square of side x plus 3. So that's x plus 3, and that little part is x plus 3 as well, is cut from a square of side x plus 4 by x plus 4, because it's a square. The remaining area, or the area remaining, is 11 centimetres squared. So essentially I've cut this away, threw it away, push, there it goes, and I'm left with like a yellow L, and the yellow L has an area of 11 centimetre squares. By forming an equation, they don't even tell us it's quadratic, but it doesn't matter, we've got to form it. For the remaining area, find the side lengths of the two squares. In other words, once we get x, we can add 3 onto that one to get the length of that one, and add 4 onto that one to get the length of the larger square. So let's just do what it says. So what do? We have big square, which is x plus 4 squared. Remember, x plus 4 multiplied by x plus 4. We're going to take away the x plus 3. Remember, it's a square because it's x plus 3 multiplied by x plus 3. And this will come to 11. Now, don't be fooled by this. Many of you would now say, oh, sir, that's x plus 16. No, it's not x plus 16. And I feel I have to show you why it's not. It's x plus 4 multiplied by x plus 4 subtract x plus 3 multiplied by x plus 3. Alright? That's why it's more complicated than it looks. Alright, so let's just do this quickly. I've got x squared, 4x, 4x, 16. Did you see that? I've got 2 lots of 4x. So I've got x squared plus 4x plus another 4x plus 16. I ain't got space to do all the arrows, alright? And we're going to take away x squared plus 3x plus 3x, and 3 3s are 9. And that all comes to 11. I've not formed the quadratic yet. I might need another page or so to do this. Tidy it up. X squared plus 8x plus 16 minus, tidy this up a little bit, x squared, 6x, 9. Worry about the 11 later on. Let's just subtract. I've got x squared, hope this is correct, anyway, x squared plus 8x plus 16 minus x squared minus 6 squared minus 9 equals 11. So let's form an equation. Doesn't even say it's quadratic. Interesting. Right, so x squared minus x squared have gone. 8x minus 6x, well that's 2x. 16 take away 9 is going to be, oh I don't know, 16 take away 9 is roughly 7, isn't it? So plus 7 equals 11. So working over here now, because I'm running out of space, 2x equals 11 minus 7. 2x equals 4. X is 2. Oh, I thought it was going to be a quadratic equation. Yeah, they didn't even say it's going to be one, so the hint is it might not even be one. Alright, that's easy. So x equals 2. Right, go back to black. So x is 2 there, and x is 2 there. question says, form an equation for the remaining area, find the side lengths of the two squares. Well, this one's going to be 2 plus 3, which is therefore 5. That's a 5 by 5 square. This one's going to be 2 plus 4, which is 6, and that's therefore going to be a 6 by 6 centimetre square. Dead easy. Right, turning over, I've got time for one more, I think. I just fancied this one. There's some other ones I could have done, but I've put a note to self. Look, as you can see, question 10, page 254. And I want to solve it and read it and do it. Anna thinks of a number, squares it, then subtracts twice the original number. The result is 15. Write down a quadratic equation and solve it to find two possible numbers that Anna could have started with. And let's just translate this into math speak. Anna thinks of a number. Oh, x. This is maths, isn't it? So let's go x. She squares it. With me? She then subtracts, that's called minus, twice the original number. That's 2x. The result is 15. Very, very simple equation. Again, bring the 15 over. Dead easy. This is nothing more than grade B. There it is. It's a simple grade B quadratic. Two factors. And now we're going to get two answers that Anna could have been thinking about. Well, x and x. There it is. How do you make 15? Easy. 5 3s or 3 5s. And please note, 5 and 3 will give me a difference of 2. If I go for a positive 3 and a negative 5, I'll have minus 5x's and plus 3x's. Well, minus 5x plus 3x is minus 2x. So I've got my two solutions. So therefore, I've got x minus 5 equals 0. So x equals 5. That's one of Anna's numbers. And I've got x plus 3 equals 0. Therefore, x equals minus 3. Does it say she's not allowed to live to negative, not allowed to have a negative number? Write down two possible numbers that Anna could have started with. Yeah, she could have started with 5 or minus 3. That is really boringly easy. Let's just check that I haven't done it wrong because it's so easy. Bring it over and minus it, blah de blah de blah, x squared, 3x minus 5x minus 2x, minus 5 times 3 minus 15. Yeah, that's it. So Anna was thinking minus 3 or maybe 5, and that's perfect. I don't want to do any more. That's enough. We've done loads in Unit 2. Here it is revisited in Unit 3, but this time, because it's geometry and algebra, we've got some questions back here where we have quadratics being formed, well, not in that case, quadratics being formed in the context of shapes. Just flipping back over what we've done in this last video. Okay, forming quadratics, context of shapes, that is to say geometry, and this is where we've come to. And I now stop. That's the end of 17.2, and work hard.